Okay, this lesson is on total surface area. So let's get straight into it. And what I do expect, of course, is as you see these notes, I want you to copy them into your maths writing book. Okay, so what is total surface area? Well, total surface area is the area around the outside of a three-dimensional object. And I can probably best explain that by using an example. So let's draw a simple three-dimensional block. Okay, so this block's a rectangular block. It's actually called a rectangular prism. So I want you to draw this down as well. So there's the top of our prism. You'll need a ruler, of course, to do this. Now you can see when I'm drawing this, that this line here is, I'm trying to keep that parallel to this line here. So, and the front and the back are also parallel. Okay, so that's the top of our box. So it's starting to take shape. Oh, not quite right. Okay, that's good enough. So there's our three-dimensional rectangular prism. It's a three-dimensional object. And this, before we can actually start talking about total surface area, we should probably become familiar with some of the language. For example, when we're talking about three-dimensional objects, the point on a shape like that, we often give that some sort of a letter. I might call that A. And that point's called a vertex. So a vertex is like one of the corners of the three-dimensional shape. So a vertex is a corner. We've also got edges. So each of these lines here represents an edge to our three-dimensional prism. So that line, for example, that's called an edge. Now the actual area of each side of the shape, this area here, that's called a face. So this is one face, and there's a face on the top, and there's a face on the side. So each of those, there's also three other faces that we can't see. We'll draw those in a moment. But each of those is called a face. So that region, that area there is called a face. Pardon me. So what I'm now going to do, I'm now going to draw in the three other faces. Because we normally couldn't see them, because they're hidden behind the front, I'm going to draw them as dotted lines. So I'll use blue, I think. So there's a line running across the back. And down the side there, and finally we've got that. So now you can hopefully see that this three-dimensional rectangular prism, this is called a rectangular prism, you can see that this rectangular prism has 6 faces. Now, we need a way of actually being able to describe these faces. In other words, communicate about different parts of the shape. Rather than saying this side or that face, we need to be a little bit more accurate and precise. So what we do, we normally label the vertices with a letter in alphabetical order. So A, B, and it doesn't really matter. The order doesn't really matter as long as you give each corner or each vertex a letter. So A, B, C, D. Call this one E, and then this one over here is called F. E, F, G, and then H. So now that we've labelled the shape with letters, we can now precisely talk about different parts. For example, if I wanted to describe this edge where I'm running my cursor, I could simply call that the edge, or the edge HE. Or I could refer to this edge here as the edge HD or DH. The order doesn't really matter. If I wanted to talk about a face, if I wanted to talk about the bottom face, the bottom of our box, I would use the 4 vertices that describe that face. So I could call the bottom face C, G, F, B, or I could have called it face B, C, G, F. All we're doing, we're describing the 4 corners of the face that we're talking about. If I wanted to talk about the front face, I could label that as, I could talk about that as face A, B, C, D, or I could even call it D, C, B, A. So now we've got letters, we can talk about the faces in more detail. So the total surface area of this shape is actually, what we're trying to do is work out the area of every face and then add them up together. So it's the total surface area of the shape. And in this shape, there are 6 faces. And so we would need to add up or work out the area of each of the faces and then add them all up, and that would give us our total surface area. So if we put some numbers in here, did an example. If I said that the edge CB was 10 centimetres long, and we said that the edge GC was 8 centimetres long, and that we said that GH was 5 centimetres long, we now have enough information to work out the area of every face of this shape. For example, I'm going to do one, and then I want you to work out the area of the other faces. To work out the area of the bottom face, now I'll just highlight this in a different colour so you're all clear what we're talking about. I'm looking at the face, the bottom of the box, the bottom of the prism. So it's this face here, and I'm shading it in white. Okay, so to work out the area of that face, and we're going to name that face, it's going to be face I'll go in alphabetical order, shall we? B, C, G, and F. B, C, G, F. So that's the white face that I'm talking about. So to work out the area, well, it's just a rectangle, so working out the area is really easy. So the area would be, it's the length by its width, so it's going to be 10 times 8, which is 80 centimetres squared. Now, I want you to pause the video and work out the area of the other 5 remaining faces. Okay, welcome back. I hope you should have now worked out the area of those faces. Let's quickly go through them. And there's actually a bit of a shortcut here. Some of you may have realised that the bottom face and the top face are the same. So this face in here is the same area as this face. So we don't have to work out the bottom one, and that will automatically give us the top one. Now we're going to work out face CDHG, CDHG. So that's this face here. That's going to be 8 times 5. So the area will equal 8 times 5, which is 40 centimetres squared. And you can possibly see, or hopefully see, that that area there is the same as the area at this end of the shape. So this face has the same area as this face. Finally, we need to work out the front and the back of the shape. So we'll work out the front, and the front face, we'll name it, we'll call it A, B, C, D. The area of that face is equal to its height, or its width, by its length. Well, it's 10 centimetres long and it's 5 centimetres high or wide. So that's 5 centimetres there actually. So it's 10 by 5. So 10 by 5, which is 50. So, therefore, we can now see that we can work out, for a rectangular prism like this, we can work out one of the sides and then just multiply, one of the faces, and double it, and that will give us the area of both of those sides. So the total area of our three-dimensional shape will be this times 2, because there's 2 of them. There's that one. It was BCGF, so that was BCGF, so that's the bottom, and then the top, remember, so we had to multiply by 2. Then the sides, left and right, that was 40 centimetres, but there's 2 of them, so we multiply that by 2 as well. And then finally, the front and back, well, that was 50 centimetres, and we have to multiply that by 2 as well. So, therefore, our actual area, our total area will be, or total surface area, our total surface area of this shape will equal 2 times 80 plus 2 times 40 plus 2 times 50. And this is how I want you to work it out. I want you to make sure you work out each face and add them together. Double them and add them together. So 2 times 80 is going to be 160, plus 2 times 40 is 80, and 2 times 50 is 100. So the total surface area will be 100 plus 160, that's 260, plus 80, that's 340. So the total surface area of this shape is 340. Because we've made our measurements in centimetres, it will be centimetres squared. And to give you an indication of what that means in reality, if we needed to wrap this up with wrapping paper, then the minimum amount of wrapping paper we would need to wrap up this present with no overlapping of the paper would be 340 square centimetres. Okay, so that's how you work out the total surface area of a rectangular prism. So you can now go on with questions 12D, question 1, and I'd like you to draw the diagrams, and then for each of those calculations set it out working out each face individually. I want you to get into practice of naming the corners, and I don't mind how you name them, provided you use letters. And I want you to work out the final answer for each of those, and then check your working in the back of the book. Thank you.